Hey, welcome to The Explainer. Today we're going to try to reverse engineer maybe the greatest mystery in the entire universe, the human mind. We're going to use Steven Pinker's incredible book as our guide, and we're going to look at the mind not as some kind of magical spirit, but as an absolutely astonishing piece of natural engineering. So let's dive in. So let's start with a puzzle. You've got C-3PO, you've got the Terminator, you've got Commander Data from Star Trek. Science fiction is just filled with these walking, talking, thinking robots. So why can't we build a real one that can just, put the dishes away? Well, the simple truth is that the things we find the easiest, like seeing, walking, just having a bit of good old common sense, those are actually the absolute hardest problems in engineering.
And this is exactly what Pinker is getting at here. Our minds aren't run by some single magical master force. Nope. Instead, they're a collection of fantastically complex little machines, each one an absolute masterpiece of design, all working together so perfectly that we just completely take it for granted.
Okay, so to even begin to reverse engineer the mind, we first have to appreciate just how unbelievably difficult the problem is that it's built to solve. This is what's often called the robot problem. To really see why common sense is so hard, just check out this thought experiment from the philosopher Daniel Dennett. Okay, so a robot needs a battery from a room, but there's also a bomb in there. Robot 1.0 goes in, grabs the battery on a wagon, and doesn't realize the bomb comes along for the ride. Boom. Okay, Robot 2.0 is smarter. It considers all possible side effects, but it's still calculating whether the color of the walls will change while boom. So Robot 3.0 tries to focus only on what's relevant, but it gets stuck just trying to figure out what relevance even means, and you guessed it, boom. This little story brilliantly shows that what we call common sense is a seriously profound computational challenge. So, how in the world does the mind solve this robot problem? Well, for decades now, cognitive science has been working with one massive idea. The mind is a kind of computer. Let's pop the hood and see what that really means.
The core idea is called the computational theory of mind. Now, this doesn't mean our brain is some kind of mystical goo. It just means our brain uses physical symbols, like, say, specific patterns of neurons firing, to represent things out in the world. So there's a pattern for your mother, another for a dog, and another for justice. And what we call thinking is just the process of manipulating those symbols according to logical rules. It's all about information processing. But, and this is a huge but, let's be super clear. This is not the simple computer metaphor. A brain isn't like the laptop on your desk. Not at all. Brains are parallel, they do millions of things at once, while computers are mostly serial, one thing at a time. Brains are slow, and their parts are kind of noisy, but they have trillions of connections. Computers are incredibly fast, reliable, and built from a blueprint. The key takeaway is that they both create intelligence through computation, but they are very, very different kinds of machines.
And this brings us to a classic and really powerful objection. If the mind is just shuffling symbols around, does it ever truly understand anything? The philosopher John Searle came up with a Chinese room thought experiment. Imagine a guy in a room who doesn't speak a word of Chinese. He gets questions in Chinese slipped under the door, and he has this giant rule book that just tells him which Chinese symbols to send back out. Now, to anyone outside, it looks like he understands Chinese perfectly. But does he? Searle argued, no way. He doesn't understand a single word. He's just manipulating symbols, which Searle said is all a computer ever does. It's a really powerful challenge, and we'll just let that one hang in the air for now. This leads us to the next logical step. If our mind is a computer and it's running all this sophisticated software for seeing and thinking and feeling, who wrote the code? And the answer is natural selection. Pinker uses this absolutely fantastic analogy. If natural selection is a blind watchmaker when it comes to designing bodies, it's a blind programmer when it comes to designing minds. Now, this is the really important part. Natural selection is not random. It is the only force in nature that can produce complex, functional design. Our mental programs, our intuitions, our abilities, even our emotions, they work so well because they were slowly shaped and tweaked over millions of years to solve the real-world problems our ancestors faced out on the African savanna. So, what kind of software did this blind programmer actually install?
Let's take a look at some of the standard equipment we're all born with. And let's start with our often very misunderstood emotions.
First things first, we need a major reframe here. We tend to think of our emotions as these irrational, primitive glitches that just get in the way of our logical thinking. This is completely wrong. In fact, emotions are the brain's highest level goals. They are the mechanisms that set the ultimate objectives for the entire system. An emotion like fear, or love, or anger, that's what kicks off the whole cascade of thinking and acting in the first place. Without goals, the whole concept of intelligence is basically meaningless. And this leads to this beautiful, kind of counterintuitive paradox. The genes that build our brains are selfish, sure, in the sense that they're selected for their ability to make more copies of themselves. But as Pinker points out, sometimes the most selfish thing a gene can possibly do is build a selfless brain, one that's capable of love, sympathy, and loyalty. All right, now for the final, crucial piece of the puzzle. We have this amazingly engineered computational mind, designed by a blind programmer. But there's a catch, a big one, and it explains an incredible amount about our modern lives. And here it is. This is the central issue. Our minds were designed for the ancestral world over on the left, but we live in the modern world on the right. A craving for scarce sugar and fat. That was a brilliant survival mechanism back then. Now it leads to a craving for junk food. The very desires that were once perfectly adaptive can become our biggest vices when the world changes this radically. Ultimately, this mismatch, this gap between our Stone Age minds and the modern world, it's the key to understanding so many of our current problems, from obesity and addiction to just that endless daily struggle for self-control. We're running software that was adapted for a world that just doesn't exist anymore. And that brings us to our final thought. Understanding that our minds are a product of evolution isn't some excuse for our behavior, but it is a powerful explanation. It's like the owner's manual we were never given. And it leaves us with the ultimate question. Knowing the quirks and the features of our Stone Age software, how can we best navigate this strange, new, modern world that we've created for ourselves?